Hey, g'day. Welcome back to my shop. In the last video that I did, I made, or at least I showed you this tool. This is a rib nut setting tool. I made this from just bar stock that I had lying around, and it's a very rough replica of a tool that I saw on a website. So I've simplified and reduced the design down to a point where I could manufacture this with the tools that I had. And it has a set of replaceable screws that allow you to use metric sizes from 3, 4, 5 and 6 millimeters. And in order for that to work, these faces have to be taken out, and the screw mechanism and this end plate have to be swapped out for the different metric sizes. When I was making this, I just bored a couple of holes in the end there so I could use a pin wrench to get some traction on this and actually do the replacement. Up until now I've been using a set of circlip pliers to do this job, and it's not ideal. You can get enough torque on that to undo it, and they do need to be relatively tight when you go to use the tool, otherwise the torque from the screw will undo that plate. So I'm a bit worried about bending these arms here, and what I need is something a bit more robust and something that I can also use on other tools that I've made. A lot of tools I have used this mechanism rather than putting a hex on the end or two flats or some other method for getting a spanner on there. I find that this is a very neat solution, but it does mean that every time you make one you've got to have a specialist pin wrench to do the job. So what I have in mind is this. Alright, so this is just a CAD drawing. Oops, get that right. This is a CAD drawing of what I intend to make, and this has been through 4 or 5 iterations before I was happy with it. A lot of the ones that I've seen require a fairly complicated joint at this end. And it's great if it's forged or if it's cast, or if you're going to machine this on a CNC mill, then you can make this as complex as you like. I wanted something that I could manufacture here in a home shop with a fairly limited range of equipment, and what I've come up with is a single arm with a single flat milled to half the thickness of the material at one end, and by making a left and a right hand half, the two can be pivoted together, and with a blind rivet or something like that, and that gives the action that you need at the end of this tool. So the stock that I'm going to use is just I think this is just 1/2 inch or 12.7 millimeter by 5 millimeter mild steel. This one I've already bent to an internal angle there of 135 degrees, which you can see here in the drawing, and this one is still just the flat stock. And if I was Stefan, I'd be using some sort of exotic tool steel to do this, but here in Australia we don't have that. It's really hard to get high quality steel. I mean, just about all of Australia is made of iron ore. We dig this stuff up, we send it overseas, and we get it back as tin cans and washing machines basically. So the Australian steel industry is pretty well dead, and the chance of getting offcuts or small amounts of high quality steel stock are just about nil. So I do have some of this stuff. It's it's going to bend if I try and over torque it, but I think for what I do it's going to be fine. At a pinch I could case harden this. That's about the only way I'm going to get sort of durability that I need from it, but we'll see how it goes. Well, here you can see me trying to bend this material in my bar bender. It did bend quite easily. It's quite soft, and I bend it around the included angle of 135 degrees quite easily. The problem is that it distorts quite badly. It certainly doesn't lie flat after this bending process. I worked on this for quite a long time in the bench vise, trying to straighten it. It had a straightness issue along its length, but it was also badly twisted as well. I had a lot of trouble using a straight edge to check it. There are simply no reference edges to work from because it is a rounded edge product. the end of the day, I decided it wasn't worth it. There was just so little material to work with. It was so thin that it didn't leave a lot of room to move when I started machining it. So as you see, I came up with an alternative material. I'm going to just scrap that. What I have got though is I've got this material here. This is 20mm by 10 cold rolled steel. So this stuff at least has a square edge and relatively uniform surfaces, and I will have to heat this up. I did try bending it cold in my bar bender, but it's just beyond the capacity of the machine. I'm pretty sure I'll break it if I try to do this bend cold. And the reason I'm starting with 10mm material is that after I do this bend, I can machine that flat to give me a reference surface, and it'll do the same thing. It'll raise this little bubble on the inside corner here, but I can machine that flat. It's thick enough that I can hold it in a vise while I do that, and then I'll be able to sand that upright in the mill vise, and with an end mill I can go along and cut that little half lap joint. It's only 3mm deep, so it shouldn't be a problem. Like organ engineering projects, when it doesn't work out, you just scrap it, start again. So let's see how we go this time. I knew I was never going to be able to bend this material cold. Here you can see me heating this with an LPG torch. I used firebricks just to retain a bit of heat around the material until I got this to a good cherry red heat. Bending this material in the bench vise was quite straightforward. I was able to pull it round close to where I wanted it and check the angle with a protractor. At this stage I had the material in one piece, so there was potentially one arm at either end of the stock. This initial marking out process was just simply to find the end points so I could cut the stock into shorter lengths to work on it further. With these endpoints marked, I can now sever the stock with an angle grinder into two shorter pieces for further processing. Now that I had the pieces cut to the correct size, I could mount them in the middle vise and face one surface. This would remove any of the distortion caused by the bending process and give me at least one flat surface set up for the next operations. Now that I had a flat surface, I was able to touch off against the top edge and the inside face of what would eventually become the hinge. This allowed me to machine a 3mm deep rebate on what would be the hinge surface. I'm using 3 thou feeler gauge stock to position the milling cutter against the face of the material. Once I have the feeler gauge stock pinched there, I can zero my DRO and then account for the thickness of the feeler stock. Now that the rebate for the hinge has been formed, I was able to reduce the width of the stock down to 14mm as shown in the drawings. Remember, this stock is way oversized when I started. It's 20mm wide and 10mm thick. The nominal dimensions of the finished arms were going to be 14mm wide and only 6mm thick. So there was still a lot of stock to remove, but it meant that I had something quite rigid to hold in the mill vise while I did any of these subsequent operations. Each of the irons is now held in the mill vise on parallels while I reduce the width of the stock. I did witness mark almost 5 out lines so I could get a visual sense of when I was very close to my finished dimension, and then I follow up with calipers to check. So the next step in this process is to reduce the thickness of this main arm down to 6mm, and I can't really think of any other way of doing it except to hold it in this vise and skim the top. It's really not the most rigid setup in the world, so I'm going to take very, very light cuts. I'm going to use one of these high rake insert cutters, hopefully so that it doesn't exert too much force on the setup. So I'm putting a previously machined surface against the fixed jaw, and I'm just going to use a piece of copper shim to clamp up against the other face. And the idea here is that if there's any discrepancy in the parallelism of these two surfaces, the copper should take up the difference. So just a bit of a tip, if you're fitting a copper shim like that, I've lost it. When you go to put it in there, of course it wants to slip down all the time, so I've just bent that at a very slight angle, and when you put it in, it just sort of grips there, and you push it down level with the top of the jaw. So one of the things with these K-type vices is that you're not supposed to grip material right at the top, and if you over tighten the vise, it will just simply pop out. So I'm just having to be a little bit careful here and keep tapping that down and make sure it's sitting on the parallels. So I'm going to be taking cuts around about 0.5mm deep, maybe less as this section here gets thinner. So this could be a spectacular fail. Let's see. What you didn't see yesterday, because my camera battery died, was I finished this cut along the bottom of the material to remove the excess stock there, and I trimmed up this edge to be 14 millimeters off this edge here. I've roughly shaped the end of this section here, which will become the pivot, and I still have to cut the taper on this edge here. What I want to do though, and what I have to do, is to locate this hole which will become the pivot between the two parts. And unfortunately this part is one of those things that doesn't really have a lot of reference points that you can work from. What I did was I went back to my CAD drawing and I looked at the position of this drilled hole, which was positioned just as an arbitrary measurement to give me enough angle on this arm here to form a reasonable pivot. I realised that having an odd measurement off this bottom edge was going to be a problem, so I've just redone the design and made this dimension here 22 millimeters off this edge, which is one of my reference edges. So one of the good things about CAD is you can go back to it and you can sort of play with it and get it right before you sort of commit to positioning features on a part. So that's what I've done. I've converted that, I think it was measurement like 21.87 or some stupid measurement, so I've just made it a whole number. What this will allow me to do is to put this edge here on a surface plate and offset 22 millimeters and just simply mark a center line across that face there. And the other dimension that I need is half the width of this section of the arm, which should be 14 millimeters. So I should also be able to offset 7 millimeters to locate that center fairly accurately. And if I do that on both parts, I've at least got one reference point. I also went back to the CAD drawing and I worked out how far it was from this drilled hole to this one, which will become the threaded hole for the pins. And once again, I just made that a whole number. So I've made it 160 millimeters. So I should be able to just simply offset 160 with a pair of dividers down toward this end and draw an arc. Draw an arc like so. And then once again, if I offset half of whatever that diameter end is, I should be able to locate that center as well. So that's the plan. I'm going to position these two holes, and then I can also work out where this taper is, this 96 millimeter taper, and machine that. And then I've just got to radius the ends. I'm sort of thinking that I might do this one on the CNC mill, just simply because it's going to be easy to hold that down, and I've only got to machine that one feature and drill the hole. This one I'm going to try using a hardened steel pair of buttons to do the radius, just for fun. So I'll show you how that works. So these are the parts that I bent up previously. These were made of some hot rolled steel, and you know, the problem was that bulge that I was getting there. At least using this stock, although I've had to remove a lot of material, I've now got dead flat surfaces and reference edges that I can work from. So I'm just going to glue these parts, and I'm going to be doing it on this side. And I made this little gadget here. This is just a glass jar that I found in a kitchen bin. And I went down to the hobby store and I bought a nice soft art brush, and I just cut the wooden handle off short and I screwed that through the lid. Previously I had to go and find a paintbrush and find a container for the blue. It's a bit of a pain. I'll just let that dry and we'll do some marking out. And just for the record, you might be wondering where this one came from. And you might have heard me say that I needed a left and a right hand arm. And I don't know why, I just had it in my head that I would need a left and a right hand one, so I went ahead and manufactured opposites. And it wasn't until I put two together I realised that I'd made a blunder, and what I really wanted was two exactly the same, which is what I've got. It's the story of my life, you know. If I need a left and right hand one, I'll manufacture two left-handed ones. If I need a pair that are exactly the same, I'll make a left and a right hand one. So, I don't know, maybe that's going to become a spare, or maybe I'll get around to making another tool one day. It's going to end up in the scrap box for now. So, let's go ahead and get this marked out. I don't know about you, but I cringe every time I see someone doing this. Digital calipers are not marking out tools. The reality is, though, that my eyesight is not that good, and for me to set up the dimension on the digital scale and then use the tool in this way is probably the best application that I could use in this situation. Yes, it's not good for the calipers, and one of these days I'll buy myself a digital height gauge and I won't have a problem. The other admission I'm going to make here is that I'm doing all this marking out on the surface of my table saw. Woodworkers out there are going to cringe watching this. I wish I had a massive granite surface plate like this old Tony. I don't have one though. So using the table saw was the best option I had. The light is fairly good in here, and also I could set the camera up so you can see what I'm doing. Apart from the marking and centre punching of the two drilled hole positions, all of this marking out is really just a sanity check for me. All of the cutting that I do after this process is done using reference edges, and scribed lines are really just there as a fail-safe. So if I mess up in my positioning using other means, the scribed lines are going to give me a warning. I still like to witness mark any of these curved edges that I have to grind freehand. The witness marks show up on the ground edge later as a small V mark, telling you that you've actually reached the surface of the scribed line. At the end of the arm that would eventually carry the pins, I pilot drilled that hole first. It was really critical that that hole did not wander. It was going to form the centre of a process that I used to form the radius. If it was even slightly off centre, it was going to make the end of that arm look terrible. Alright, so what you didn't see off camera was me making these three silver steel washers. These are just an arbitrary thickness. They've been drilled through at the same diameter as the tapping size for an M4 bolt, which is going to be used as the actual pin for the pin wrench. And it just so happens that a 6BA model engineer bolt will fit through that hole fairly snugly. So what I'm going to do is to fully harden these three washers, and there'll be one place on either side, and they'll be held in place by the bolt and a nut, hex nut, and these are going to be used as the filing button to get the radius on the end of this arm. The idea of fully hardening these is that you file down very close to the button, and when you're really close you switch to an old file, one that you don't mind damaging, and you just do the last little bit of cleanup using that old file, and of course it's just going to skid on these hardened buttons, but it will cut the parent material. So what I'll do now is just heat these up, get them red hot, dunk them in water, and they'll be fully hardened. So I just want these to be cherry red, and we'll dunk them in water. You can temper them if you want to. I don't probably see the point just for this application. And the reason why I have 3 of them will become obvious later. But for the start process, just rounding the end, I only need 2. Okay, so that's done. So all we need to do is put a button on either side, put the bolt through, tighten up with a nut. And the next step is going to be to machine a taper on each of the arms. And I want these buttons to be in place when I do that, at least when I do the setup. And these are going to be used to locate the exact position of the tapered cup. So let's go and look at the mill and we'll see how that works. Okay, so the deal now is that you can place your stock in the vise, and the buttons on the right hand end are resting down on the vise jaws. And just give that a bit of a tap to make sure that's seated. And of course the idea is that you want this previously marked out line. I've scribed a tapered line there. I want that to be parallel to the vise jaw. So with my 3rd button, I can place that on top of the vise jaw, and with a little bit of tapping we can get the line tangent to the top of that washer. Now my eyesight's not what it used to be, and I'm going to get a magnifying lens on this so I can check that I've got it right. In reality, this tapered line is just decorative, so even if I get it wrong, it doesn't really matter. So this is just being a bit pedantic really to get it as close as I can. So I'm going to do this off camera. I'm just going to give this a bit of a tap this way and that, try and get that parallel, and then I can remove the buttons at this end. I don't want them in place when I do the milling, and I'll take that tapered section off. So stand by. Okay, so I got a decent light on that, got my magnifying lens, gave a bit of a tap with a copper knocker just to get that down as close to the line as possible. And if I zoom in here, hopefully you can see, I got that pretty right. So I'm going to get set up now for doing the cut, and we'll trim off this tapered section. We'll do that on both arms, and then we can have a go at radiusing the end. I realise here I'm just eyeballing this. Probably I could have done something really special with a, I don't know, DRO and touching off on the button. Once again, is it worth it? Just for a decorative cut? Probably not. So what I've done is I've just roughly cut the end of that arm close to the marked out line that I had, and I've reassembled those 2 hardened steel buttons through the hole, and all I need to do now is just trim off the excess till we hit the button. So that I'm going to use an old file when I get really close, and you'll hear it skid. It'll just skid around the surface of those 2 buttons and give us a perfect radius on the end. So I'm just going to start by cutting a series of flats, and then I'll blend it all to finish. I don't know if you can hear that, but I can actually hear the file skidding over the surface of that button, and you sort of feel it as well. In case you're wondering, this is an old file, it's not one that I use for precision work. And I can sort of feel now that there's not much cutting going on. It really is just skidding. So I reckon that's just about done. A little bit still there. No, that's it. So I'll probably just draw file this to finish. Yep, I reckon that's done. That's not bad. Well, I spent a lot of time setting up the camera and tripod to get this shot, and then promptly stuck my big fat hand right in front of the camera. But what I'm doing here is tapping the end of the arm that will eventually carry the pins. The tool that I'm using is a George Thomas designed tapping and staking tool. It's configured so that I can cut threads perfectly perpendicular to a surface, which in this instance was really important. I reasoned that the pins do need to be parallel and they do need to be perpendicular to the face of the arms, just to stop any chance of the pins torquing or slipping out of the holes that you're trying to tighten. So there's the socket head screw through the end of the arm, and it's just a matter of turning down this section of thread here to make whatever diameter pins that I need. Right, so what I've done off camera was I've made a shouldered screw which is going to hold the two halves of this tool together. So this is just a piece of silver steel. I machined down a length of that to 5mm diameter, and the distance between this shoulder and this shoulder is the combined thickness of both halves of the tool plus about 0.05 mm. And the thinking is that if I can tighten a nut down onto this section, which will be threaded at M4, and the nut comes up hard against that shoulder, it's going to hold the two halves of the tool together with a tiny amount of clearance. What I'm hoping to get is a joint like this one on my Jenny calipers, and I've had this tool for years and years, and through some sort of devil magic they get the nut and the domed, the screw and the domed nut on this side to hold together and make that joint firm, and it still allows it to move and hold a dimension, but it's never come loose, so I'm a bit reluctant to pull it apart and see how it's done. There may be some sort of spring washer involved, I'm not sure, but that's the sort of joint that I'm hoping to get on the end of this tool. So the next step is going to be to put an M4 thread on here. I'll have to do a little bit of thread relief at this shoulder here and then make a matching nut. I'll part this off and do a sort of a decorative treatment on the outside of that. Well, as you can see, I've finished the two arms. I've actually gone around, draw filed everything. I broke the edges with a small file and I polished it to about 90%. I've got a really bad habit of polishing something to about 90% and then I just go, meh, that's close enough. And for what this is, given that it's probably going to go rusty in a couple of weeks anyway, I think that's going to be fine. I've also found a couple of 4mm metric socket head screws which are going to be machined down to make the pins. We'll have a look at that process shortly. And I finished the screw and a nut to hold these two parts together. And I know what you're going to say, but let's have a look at the process. So the two halves just go together like so. The screw goes through, and the nut was actually made from the head of an aircraft grade bolt. So these are high tensile, I'm thinking probably containing a certain amount of titanium and nickel, but they're quite hard and very, very durable, of course, and surprisingly light, which I'm guessing is perfect for the application. So all I did was I just faced that off, I centre drilled through and tapped M4, and then I just hand shaped that with a file to put a bit of a domed head on it and polish it up, and we've got that. So that can be tightened up, and I know what you're going to say, the irony of having to use a pin wrench to make a pin wrench. But you know what? I embrace the irony. The alternative was to make another hex head bolt, and I just couldn't be bothered. So here we go. It's just going to be my little private joke. And I want this to be so that you have to really torque it down in order to bring the two halves, or the two arms together. And I don't want to have any shake or movement there at all. And that's sort of the way I want it. So that's sort of holding. I don't want it to be super tight. That's okay. And there's the pair of holes in the head of the screw, and there's the face of the nut. So the final step is to machine the pins on these M4 bolts. So this is I made a pair of these. These are 2.5mm pins on the end of an M4 socket head screw. I can make whatever size I want basically, and just fit them to the ends of the arms in the tool. I'm going to have a go at making a set with 3mm diameter pins. We'll have a look at that process in the lathe. The tool that I've used to do this is a lantern chuck. This is a DIY version, and it's just a threaded spindle. Thread diameter and pitch doesn't really matter. I use 16mm metric because I just happen to have some 16mm metric nuts. These had a circular disc face silver soldered onto the end, and I just cleaned it all up and bored out the centre to take a set of brass plugs basically, and these can be made in whatever size you need. And for this application I've made these so they're a snug fit on the M4 socket head screw. So all you need to do is to put your socket head screw through the brass plug in the centre, and it's a bit awkward, like so, and then tighten that up on the spindle. And what that allows you to do is to do whatever you like to the end of the thread. So you can shorten it, you can chamfer it, you can turn away some of the thread if you want to. And ordinarily that would be really hard to do in a standard 3-jaw chuck. You'd end up closing the chuck jaws on nearly all of the screw, and even then you wouldn't be able to hold it very securely. Works really well for things like countersunk head screws or round head screws that you would find almost impossible to hold. So let's head over to the lathe and have a look at the turning process. So I've already got one of these pins in, and here's the second one. And now you can see the protruding sections of the pin and the M4 screws. So these can be swapped out for whatever size that you think that you might need. So just to wind up this video, this is the rig nut tool I made in the previous video, and the whole purpose of making the pin wrench was so that I could swap out these faces in the end of the rig nut tool, and the pins can go in and you can loosen and tighten that and put a fair amount of torque on this face without doing any damage. Of course, this is only mild steel, and you know, if you really went to town on it, you would bend or at least elongate the threaded portion through the end of the arms. But for what I want it for, it's going to be fine. So there it is, rig nut tool, pin wrench. Thanks for watching.